This is Physics 2. There's no part 1 because I didn't make it. So, this is the more fun one. Anyways, so this is the first part of, this is the very beginning. I've kind of just winging it, don't have a plan, kind of just made this, gonna do it. It's actually just my homework. And if you want to learn some science beyond your grade, stay tuned. Okay, so excess electrons are placed on a small lead sphere with a mass of 8.45 grams, so that its net charge is negative 3.90 times 10 to the negative 9 coulombs. I'm just going to start saying coulombs. The first question is, with this information, is how many extra electrons does the sphere have? Okay, so we're going to read the entire chapter 21 to answer the question. So that's what we're going to do. The objectives are the nature of an electric charge and how we know that an electric charge is conserved, how objects become electrically charged, how to use Coulomb's law to calculate the electric force between charges, the distinction between electric force and electric field, how to calculate electric field due to collection of charges, how to use the idea of electric field lines to visualize and interpret electric fields, how to calculate the properties of electric dipoles. So some stuff that they say we need to know kind of already is vector algebra, including scalar dot product and the vector cross product, which is, if you know the rules, it's not too bad, it's doable. Newton's second law, stable and unstable equilibria, streamlines in fluid flow. I don't know what that is, but whatever. Okay, so in chapter 5 we mentioned the 4 kinds of fundamental forces. To this point, the only one of these forces we have examined in any detail is gravity. Now we are ready to examine the force of electromagnetism, which encompasses both electricity and magnetism. Electromagnetic interactions involve particles that have electric charge, an attribute that is as fundamental as mass. Just as objects with mass are accelerated by gravitational forces, so electrically charged objects are accelerated by electrical forces. The shock you feel when you scuff your shoes across a carpet and then reach for a metal doorknob is due to charged particles leaping between your finger and the doorknob. Electrical currents are simply streams of charged particles flowing within wires in response to electrical forces. Even the forces that hold atoms together to form solid matter and that keep the atoms of solid objects from passing through each other are fundamentally due to electrical interactions between the charged particles within atoms. We begin our study of electromagnetism in this chapter by examining the nature of electric charge. We'll find that the charge is quantized and obeys a conservation principle. When charges are at rest in our frame of reference, they exert electrostatic forces on each other. These forces are of tremendous importance in chemistry and biology and have many technological applications. Electrostatic forces are governed by a simple relationship known as Coulomb's law and are most conveniently described by using the concept of electric field. In later chapters, we'll expand our discussion to include electric charges in motion. This will lead us to an understanding of magnetism and, remarkably, of the nature of light. While the key ideas of electromagnetism are conceptually simple, applying them to practical problems will make use of many of your mathematical skills, especially your knowledge of geometry and integral calculus. For this reason, you may find this chapter and those that follow to be more mathematically demanding than earlier chapters. The reward for your extra effort will be a deeper understanding of principles that are at the heart of modern physics and technology. You think I get in trouble for posting this on YouTube?
I don't think so. You just put one of those disclaimers like, this is just for assistance. Information is taken from this book for, no copyright intended. Like when people put stuff, like, are you concerned about, like, because you're reading from the book?
And then posting it on YouTube?
I don't think so. I mean, worst case scenario, somebody contacts you to take it down, but.
That would suck. The ancient Greeks discovered as early as 600 BC that after they rubbed amber with wool, the amber could attract other objects. Today we say that the amber has acquired a net electric charge. Son of a bitch, man. Or has become charged. The word electric is derived from the Greek word electron, meaning amber. When you scuff your shoes across a nylon carpet, you become electrically charged, and you can charge a comb by passing it through dry hair. Plastic rods and fur, real or fake, are particularly good for demonstrating electrostatics. The interactions between electric charges that are at rest, or nearly so, after we charge both plastic rods by rubbing them with a piece of fur, we find that the rods repel each other. Ooh. I'm gonna do it right now. I'm gonna rub 2 plastic rods on Sophie and see if they repel each other. Doesn't work. I need a different kind of plastic. Doesn't work. I tried it and it doesn't work. I tried markers and plastic chopsticks. It doesn't work. Diagram says if you rub 2 plastic rods on fur and then try to put them to each other, they will repel each other because of the electrical static charges that the fur rubbing caused.